Assalamualaikum warahmatullahi wabarakatuh. Now, I will introduce my group members. First, Umaira binti Mazahar. Second, Pang Xiaodong. Third, Li Chi Wei. And last, Nur Inani Najwa binti Jamaluddin. Introduction. Simple linear regression is a statistical method that allows us to summarize and study relationships between two continuous quantitative variables. First, one variable denoted x is regarded as the predictor, explanatory, or independent variable. Second, the other variable denoted y is regarded as the response, outcome, or dependent variable. We will refer to the variables presented in this course as predictor and response because the other words are less commonly used today. The other terms are merely mentioned to alert you in case you come across them in other contexts. Because only one predictor variable is studied in simple linear regression, the term simple is used to describe it. In contrast, the term multiple refers to the study of two or more predictor variables in multiple linear regression, which is what we will cover later in this course. For the aim of conducting this study, we also canvass UTHM students. We offer online Google Forms to UTHM students. The two main questions we asked were grade obtained on the test and the number of study hours. We included 3 extra questions about gender, faculty, and year of study in order to further analyze data. The study examines the relationships between exam result and the number of hours UTHM students spend studying and reviewing their lectures. The independent variable is the number of study hours, while the dependent variable is grade obtained on the test. Since the amount of study time has a significant impact on exam outcomes, we chose this variable. The survey's main objective was to gather data and ascertain whether the number of study hours students put in affects their final grade. Therefore, utilizing the survey from this Google form, we may analyze for the data of UTHM students who responded to this question. We perform the necessary calculations, convert the data to graph, and then present the summarized in numbers. Scatter plots. A scatter plot is a graph of the ordered pairs x, y of numbers consisting of the independent variable x and the dependent variable y. This is data the relationship between students' study hours and their grades achieved. X refers to student study hours, which is independent variable, and y refers to grades achieved, which is dependent variable. And then the graph refers to the relationship between study hours and student grade. This graph displays the scatter plot produced by the data from the Google form. The student study hour data are displayed on the x horizontal axis, while their grade is displayed on the y vertical axis.
Good day, I'm Pang, and now I will continue with the simple linear regression model. So, In statistic, linear regressions is regressions analysis that model the relationship between one or more independent and dependent variables. So with this, it can help us to perform a statistical analysis on the linear regressions result, and it also can allow us to know and see the predictions based on the data that we get. So there are two main objectives that I need to mention here is the find out. The first objective is to predict the unknown value by the data that are already have, and the second is to find out if there is a relationship between two variables. In our case, the relationship is between the study hours and the student grade achievement. And we'll move to the next, the least square method. So the least square method is the equations of the least square line that will enable us to predict a student grade based on his or her study hours. And with this, we are able to interpret the result. And this is the formula, which is the y equal to beta 0 plus beta 1 multiply x. And I will explain this formula. So y is the dependent variable, which is the value that depends on something else. And it is labeled on the y for sure. And x will be the independent variable. It is plotted on the x. Okay, so the beta 0 is represent the slope of the line, and the beta 1 is equal to y intercept. So we move to the calculations. So the first thing first, we have to find out the slope. So, and this is the formula, which is the beta 0 equal to y minus beta 1 multiply x. And to find the beta 1, which is the y-intercept, we have to find out those two values first, which is the s(xy) and the x(xx). So below it are the formula. So before that, we need to find out those values. Those values are from the table that have made in our report. So we have to find out the submissions of x, which is represent the study hours, and the submissions of y, which is represent the grade achieved. Okay, and the submissions of x squared 2, submissions of y squared 2, and submissions of xy. So these are the values that we have calculated, and the mean x is the means of the study hours, which is x is equal to 2.8, and means y, which is the grade achieved, is 4.96. So after that, we can start to do our calculations. The first step is to find out the s(xy) and the s(xx). So with the formula below and the submissions that we have gained from the table, just put inside, and after all the calculations, we have gained a value. So the s(xx) is equal to 21.86, and the xxy is equal to 16.02. So the step 2 will be the step that we need to find the y-intercept and then the slope. So we have to follow the step first, which is we have to find the y-intercept and then the slope. So with the formula that I have already explained, put inside the value that we have gained from step 1, which is the 16.02 divided by 21.86. We will get a number of 0.73. That is the value of beta 1, and put inside the formula of beta 0, we'll gain a value that is equal to 2.91. So, and then the final step is do the equations of least square line. So after all the calculation, we have found out y equal to 2.91 minus 0.3 multiplied by x. So we can conclude with when the student study hours is increased by 1%, the grade achieved by student will also increase by 0.73%. Okay, that's all is my part, and thank you.
Now, I will talk about the coefficients of determination. The coefficient of determination is well defined in linear regression module. It can measure the proportion of variations in the dependent variables explained by the predictors included in the module. The formula for the coefficients of determination is r squared equal to xxy squared divided by the result of xxs times xyy. The xxy is the sum of the product of the difference between x is mean and the difference between y and its means. After that, the xxx is the sum of square of the variable x, and the xyy is the sum of square of the variable y. From the previous part, we can get to know xxy is 16.02 and the xxx is 21.86. After that, we calculate the xyy, and the result we get of the xyy is 13.77. Hence, we can substitute three values into the formula for coefficients of determination. Now we get to know the coefficients of determination for our study is 0.8526. Thank you. I will continue the presentation with coefficient of Pearson correlation. A correlation exists between two variables when one of them is related to the other in some way. The coefficient of Pearson correlation measures the strength and direction of a linear relationship between the two variables. The symbol for the sample Pearson correlation coefficient is R. The symbol for the population correlation coefficient is P. When R is between 0 to plus minus 0.5, the correlation between the variables is positively weak or negatively weak. But when R plus minus 0.5 to plus minus 1, the correlation between the variables is positively strong or negatively strong. There is no correlation between the variables if R is equal to 0. So as you can see here, the formula of coefficient of Pearson correlation is R is equal to Sxy per square root Sxx times x times Syy. Next, for the calculation, we will use the value that we got from the previous calculation. So as you can see here, Sxx is equal to 21.86. Sxy is equal to 16.02. Syy is equal to 13.77. So we will use the formula R is equal to Sxy per square root Sxx times Syy. So R is equal to 16.02 per square root 21.86 times 13.77. So the answer is R is equal to 0.923.
For conclusion, regression is a statistical method for determining how one or more independent variables and a dependent variable are related. Also, regression analysis is a statistical method for determining how closely variables are related. Additionally, least square is the general answer that reduces the square sum of errors created in each and every equation's output. As a result, we can conclude from the study that have been done that one of these responsive variables depends on one or more predictors. So that's all from us. Thank you.